Too. Okay, so you have the PowerPoint for the chapter, the class recording after class when it gets uploaded. I will share the link here. So it's just a placeholder, not available right now, but will be available. I'll send you an email. And then YouTube video tutorials, short ones. There's a chapter 1 and 2 review, which is like a quiz. And then you have an assignment problem for chapter number 3. This is your assignment number 2. Whatever was assigned last week is due by midnight tonight. Okay, so now chapter number 3, which is about using methods. Again, half of this chapter is not new stuff. But the other half of the chapter, you will find that you're learning stuff which is very specific to Java. What is a method and why do we use one? This was covered in Intro to Programming class where you learn about modularization, which is taking up a huge task and dividing it up into smaller, more manageable tasks. And each small task is given a name and it's given a code block. How do we create code blocks? By using curly braces. If it receives parameters, we will use the parentheses for that purpose. Otherwise, it's empty. So this is the same idea. It's the same idea that some languages call it functions, some languages call it procedures, some languages call it methods. So Java calls it methods. That's the word Java uses. So we will stick to that keyword when we are in this class. In C#, whatever Alan uses, you will be using that word. Anyway, so to execute a method, you can make a call to a method, which is called, you can invoke a method. So there's always one method in your application, which is the main method. If main method makes a call to another method, main method becomes a calling method, and the method that you are calling becomes a called method. So these are two other terminologies: calling method and called method. So let's say in this figure 3-1, we have a main method. The main method is a method. It uses parentheses and it takes a parameter and it displays an output, smart electronics. Is main making a call to any methods so far in this example?
String?
String is a data type, right? Remember the basic rules, Alex. Method must always have what next to it? Parentheses. Does string has parentheses after it?
Print.
All right. Print line. Exactly. Exactly. So always remember the basic syntax. Methods will always have parentheses after that. There is nothing else in this language that can have parentheses but methods. So there's only one method main is calling, which is println. But println is a built-in function or built-in method, but that doesn't mean it's not considered a method. It will still considered be a method. Okay, now let's have a look at this one in figure 3-2. Is main calling any methods?
Yes.
Yes, which is same method println, right? But what do you notice difference between in the behaviors of figure 1 and 2?
Well, besides it's passing through multiple times with different information.
Okay, so we would rather use the word it is calling rather passing.
Okay?
Thank
you.
So we are calling println multiple times. So that means that once a method exists, you can call it any number of times and it will work. Every time you call it, it's loaded into the memory, it works, and at the end of the process, it goes out. Now, yesterday in control language class, we talked about a special memory called stack, where method calls are generated and placed. And that's exactly what we are now going into Java. Same idea, that anytime a method is called, it is placed on top of the stack, just like we looked at an analogy yesterday, a stack of trays. And when the method is done, just like the top tray goes off the stack, the first one to come off the stack, exactly the same way, the method that is called the last is at the top of the stack, is the first to expire, go off the stack. So the tray underneath, which is the method underneath, automatically comes up the stack. So every time a method calls another method, the caller goes down the stack, the called comes up the stack. If called calls another method, then called is one step down, and then whatever it's calling come one step up. And like that, it keeps going. Okay, here, if you look at this example, how many methods is main calling?
Two.
Two of them. One is println, which is user defined, and one is display hours, which is somewhere that the system knows. It's user defined, okay? Now, println is not local method, so that's why it needs an entire path. You cannot just call println. You need to give it a context that first go to the class system. Inside the system class, I want you to look at an object by the name of out, and then println is defined inside the class to which out belong to, which is the print stream. Here, display hours, if it exists within the class, you can just directly call it without having to reference anything, okay? So that's what basically the difference between the two is. Okay, this is basically the complete picture. So println in figure 3-5 is an outside method, so it needs a whole point of reference. Display hours is an inside method, as you can see right here underneath the main. That's why you can just call it by name. When main calls display hours by name, main goes down the stack, display hours comes up the stack, display hour displays what it is supposed to do. When it is done, control comes back to main, and then the main ends because that's the last instruction to process. So this method call invokes the method display hours. Now, display hours and main have very similar header, public static void. The difference is in the name, and display hours takes no parameters, where main takes one parameter. That's the only difference. But the rest of the syntax is exactly the same. All the methods that you are learning in this part of the chapter are static methods. Static methods, that's why they have the word static next to their names. But you will also learn about non-static methods. And when we learn about non-static methods, that's when we will learn about the difference between static and non-static methods. But for now, we are concentrating on static methods. Static methods are class level methods. So any static method can call any other static method without a problem. Okay? If a static method is in a different class, then you can use the name of the class and then call the method. Now, let me take you guys back to chapter number 1. In chapter number 1, look at figure 123. Show message dialog. Is that a method? Right? Because it has parentheses after it. How many values does it take in? 2, null, and first Java dialog. What do we call these values that are taken by the method? Parameters. Okay. Now, show message dialog. How are you calling it? How are you locating it? Because it's not in the local class. You're saying, give me J option pane. And then J option pane is not in the local package, so we imported the package from where J option pane is coming. So give me J option pane, and through J option pane, I can locate show message dialog. Everybody understood this part? Okay. Now, keep in mind, can you tell me the syntax of console output? system dot out dot println, correct? Now, what is the difference between the two syntaxes? This versus that. In this one, the method is being directly called by the class, right? JOption pane is a class, dot method. There's nobody in the middle, nobody in between. Look at the second option. What does it say? Is println directly called by system?
No, there's out between.
In between, there's out. And what is out? It's an object, which is declared inside the system class, but the object is of printWriter class type. So if a method is called by an object, listen to me again. If a method is called by an object, the method must have been declared without the word static. That's a rule to remember. If you see, and how can you tell if it's a class or an object? Classes are always Pascal cased. Look at JOption pane. The first letter is uppercase. Look at out. The first letter is lowercase. So that's why visually you can see if the object is calling or the class is calling. So if an object is calling a method, the method must have been declared non-static. If the method is called by the class, the method must have been declared static.
Can you repeat that one more time?
Okay, yeah, I'll do that. If a method is being called by an object, the method must have been declared non-static.
Thank you.
And the second part is, if the method is called by a class name, then the method must have been declared as static. Okay, that's basically always, this is something that you will see over and over again for the rest of this course and the next course in Java. Always will be the case. So visually, you can see if it's Pascal case, calling a method, static. If camel case calling a method, the method has to be non-static. Okay, now having said that, let me clear the annotation. Okay, let me go back to chapter number 3, where we were. Inside here. Okay. So display hours is inside the same class. So display hour doesn't need any reference to be called. But remember one more thing. If a static method makes a call to another method and gives no points of reference, just makes a direct call, that method that it is calling must be static. If a static method calls another method without any reference, just directly calls it, then the called method must be static, because static methods cannot call non-static methods without reference. So that's third rule to remember. So we looked at 3 rules. Rule number 1, if a Pascal case item calls a method, the method has to be static. If a camel case item calls a method, the method has to be non-static. And rule 3 is, if a static method makes a call, direct call to another method without any reference, the called method must be static, like in this case. So this will help you in code reading. Also, these rules will help you in coding. so that you do not code incorrect code, and always keep the reference. Now comes in mind another question. Okay, we understand static, non-static, but why? Why? If you want a single copy of method running in memory, and that copy is the same copy for all the objects of the class, then you have to create it as a static method, one copy at any given time in memory. And that copy is the copy that everybody sees. Everybody sees the same version of the copy. Non-static, on the other hand, can run many copies of different variations at the same time in memory. Okay, now to help you understand that concept, let's go back in chapter number 1. Let's go to the right place in chapter number 1. Here we go. You guys remember this diagram from chapter 1? Okay, so there are 3 dogs. Each dog has a name. Each dog has an age, a breed, and shot status. Okay. So if I want to change the name of dog, Ginger, to something else, I should not have to change everybody's name just to change Ginger's name, right? So I need to create a method that only works for Ginger. This method is called non-static, that only works for one instance or one object of the whole class, because it only can access the memory of one object in the class and change whatever changes I want to make. Okay? Now, if these 3 dogs are in a shelter home, and they're in the same shelter home, and the ownership of the shelter home changes, and now the new owner wants to give the shelter home, a new name, will that be the same name for all 3 dogs? Because they're in the same shelter, right? The previous name was the name of the shelter for all 3 dogs. The new name will also be the same name for all 3 dogs. So the method I will use to change the shelter name will be static, because whatever it is same for everybody. And the methods that I will declare to change individual properties of individual instances, that will be non-static. Okay. Similarly, the method to change the address of the shelter home, will that be static or non-static? The address of the shelter home.
That will be static.
That'll be static because it'll be same for everybody. Okay. Phone number of the shelter home. Static or non-static?
Static.
Static, because it's same for everybody. Okay. But if I want to change the shot status of Bowser, will be static or non-static?
Non-static.
Non-static, because I'm only want to change Bowser's shot status. Okay. Similarly, if I want to change Roxy's age, will that be static or non-static? Non-static. Okay. If I want to, if the manager of the shelter home changes, will that be static or non-static?
Static.
Static, because it's changed for the entire facility. Okay. So that's basically to give you an idea of when you would do something static and so when you would do something non-static. But initially, all the methods that you will code will be static, and then you will transition to non-static only when you are working at instance levels. Okay, so let's transition back to where we were in chapter number 3, section 3.2. So it's very important for you to understand the method's body. The method's body includes the curly braces. That's method's body. Whatever you want to put inside the method body is in curly braces. And whatever is whatever you write outside of the curly braces, before you start the curly braces, that is called a method header, which is also called method declaration. These are the two other terminologies, method header or method declaration. What are some of the things that are part of the method declaration? Public, static, void, method name, and parentheses. And inside parentheses, parameters are optional. If you want to have parameters or you don't want to have parameters. In Java, even if the parentheses are empty, you still have to put parentheses. Okay? Technically, a method is not required to contain anything inside its body, but practically speaking, you would not do it otherwise. Sometimes while developing a program, the programmer creates an empty method as a placeholder because you'll be like, okay, we may need it in the future, but we don't need it right now. So as per the UML diagram, I need to code a method, but we don't have any implementation for this one right now. Maybe in the next cycle we will. Such methods are called what? A stub. Okay? The method header is the first line of the method. It contains optional access specifiers. What are access specifiers? Public, private, protected. There are three of them. Okay? An optional static modifier, well, if it's a static method, you have to use static. A return type if needed, if it's a value returning function. An identifier, which is the name of the method, and a parentheses, which could be empty if it has no parameters. Okay, have a look at this diagram. Public is access modifier. Static is another modifier, which we learn about. Void means the method is non-value returning. Same concept as in C#. Main and display hours are called the method identifiers, which are the names of the methods, followed by parentheses, which could be empty or could have a parameter. Any questions this far? Okay. We learn about static. Okay. Void, we learn about void. It's a non-value returning. So when a caller makes a call, caller doesn't get any value back. On the contrary, if you replace it with a data type, that becomes a value returning method. Followed by the method name, which is called the identifier. What is the naming convention for method name? Is it Pascal or is it Camel? Method name. Pascal case or Camel case?
Pascal.
Okay. Can you give me definition of
case.
the Pascal case?
Or camel then. It's
Camel, because first letter is lowercase, right? Pascal's first
Yeah.
letter is uppercase.
Oh. Yeah.
Okay, let's transition to and parentheses if are needed. I mean, like parameters if needed. Parentheses will be there always. Okay, having said that, let's start putting something together. So how about you guys open Eclipse? I'll stop sharing for now, and I'll wait for everybody to give me a green check that your Eclipse is up. And then we will go from there. I'll share again once I see green checks from everybody. Please give me green checks on the video versus in the chat. And you can find these green checks in the reaction. So you click on the reactions and you can find the green checks there.
Uh-oh. Um, it's loading.
It's fine. It's fine.
I was deleting files and I deleted the wrong one. Okay.
Still waiting for 4 people. Oh, Anwar is here. Hi, Anwar. Let me update the attendance sheet. Okay. Uh, by the way, is Connor here as well, or is Connor still missing?
Still missing.
Still missing. Okay. So Connor is the only one missing right now. Okay, so Luke, Tyler, and Anwar, 3 more people. 3 people need to give me green checks or
Oh, I'm sorry. I'm on my way back home because I went
oh,
to the in-person class and I realized that.
you okay.
So,
You looks like you have not
you can
you
go.
have been ignoring my emails, Anwar.
Yeah, I did not see it.
Yeah, remember everybody that we will be on Zoom for at least another month and a half. That's what I sent in my email, and I mean, for next 6 weeks. So I hope you don't live too far from campus, Unver.
20 minutes. I'm already
20
home.
minutes?
I'm just backing into the driveway. So I'll be on in a bit.
Okay, yeah. Okay. I mean, like, didn't have to drive too much to slow down. Okay. Okay, cool. So let me share my screen again. Let me first clear the participation panel, and then we will share the screen. Okay. So I will be creating a new Java project for this week. Week 1 was the Java project for last week. So you can do however you want to do it, but that way, it will be easier for me to keep track of the weeks. So we are in week 2 right now. And remember, you need to uncheck if create module is checked. Very important step. Okay, right at the bottom, under module, it should be unchecked because you unchecked it last time. But for any reason, if it is checked, make sure you uncheck it before you move on to next and finish. And we will now be creating our very first class by right-clicking and creating the class. The name of the class that we will be creating is our college info class with a public static void main. Okay. So first of all, I will be creating 10 blank out statements, and then I'll be filling those in. So 2, 3, 4, 5, and 10. These are total of 10 system.out instructions, blank ones.
Oh, that's fine.
Oh, campus Racine. Credits 63 and faculty. So just a basic, very, very basic program right now. We will modularize this program, but for now I've put everything in the main. And when you run this program, you will get output in the console. I did not create any package, Luke. I'm working with the default package. So I just directly went to File, New Project, and then inside the project, I just right-click on Source and went to New Class. So it's under the default package. I did not give my package any name. Cool, no problem. Okay, so everybody got at least this much running? Now let's start modularizing this. So what modularization does, it lets you take something big and start dividing it into smaller chunks. What we learn in the chapter is that these words are exactly the same for all the static methods, public, static, void. So I'll copy these three letters and paste it. Public, static, void. The method needs to have a name. So let's say I create a method called college, and method needs to have parentheses and curly braces to make the body of the method. So public static void, the name of the method, parentheses, and the body of the method. Okay, so one is information about college. So the first three lines I have, gateway, established, president. I can move these lines right from main into college, just like that. Just move those three lines into the body of college. And in place of those three lines, simply make a call to college. So calling method college. So you're calling the method, college. And when you save the changes and run the program, do you see any difference in output? You will not. Because see, all we did was, instead of hard coding the lines inside the main, we pushed those hard coded lines in another method. And in the same location, we called that method. So since we called it at the same location, during runtime, those three lines will come in that same location. Now what we will do is we'll create another method, public static void division. And I will move the two division lines into that method. And then I will make a call to division method right after the college method. Calling method division. Now, I want to create a public static void method called department. And then I want to create another public static void method called program. So I have two methods, department and program. Okay. What did we learn in the chapter? Any method that has no instructions in its body, what do you call those methods? Stubs, right? Stubs. Okay, right now these are stubs until you start giving them instructions. So there is only one department instruction. So that's the only instruction. We will move inside the department. And the rest of the 4 instructions, software developer, Racine, 63, and Alan, Saad, and Wendy, we will move them in the program. So right after division, I will make a call to department method. So calling method department. And then right after that, I'll make a call to a method called program. Calling method program. And go ahead, run your application, and you will see no difference in output than what you had the first time. The only difference is that we have put them in different buckets. So it becomes a lot easier to manage them. So all I did was I took those 10 instructions and I divided them between 4 methods that we created, and then we are calling them from main. The order in which you call the methods is the order in which the output will be displayed. So now you can control in whatever fashion or whichever manner you want these to be done. Now let's learn about maintaining or improving methods. So let's say I go to the department method, and in the department method, I write some more instructions, such as programs. And then I start listing IT programs, like we have computer support specialist, we have network specialist, we have cybersecurity, we have web software, we have software development program, we have data analytics program. So I just listed the programs in acronyms. Okay. Save the changes and run the program, and you will now see that the changes that you made reflect in the output. And you did, now think about it, if main were 300 lines long, you would have to locate the place where you have to make a change in the main and then make the change in the main. So it would become a little bit cumbersome. So now I know that there is a designated method called department. I go to that method, I make the change to that method. So it's easy to maintain and manage. Got it, everybody? Okay. Now, if we look at the college method has 3 sets of information, right? Out of the 3 sets of information, which information can change over the period of time? If you're muted, unmute yourself. President, right? So that is something that I can create parameter for. Anything that is customizable, that's where the parameters kick in. So let's go to line number 10 and let's declare a parameter called president name. And that parameter, I will now delete the Ritu Raju, and I will concatenate the string president with the president name. So anything that is customizable, you control that with parameters. Now you will notice that line 5 is an error because there's a mismatch. College expects a parameter, but the college on line 5 is not passing one. So now let me pass from here. Let's say I write Brian Albright. Save the changes and run. You will now see that the president college shows as Brian Albright. Now, if I copy this and paste it again, and then I pass Ritu Raju. So I'm calling the same method twice. One with Brian Albright as a parameter, the second one as Ritu Raju as a parameter. So you will see the output of the college method twice because I'm calling it twice. Okay. So if I make a modification here next to Brian Albright, let's say 2007 through 2022. And
It's not doing the college twice for me for the president.
okay, just 1 minute and I'll have a look at it. Okay, so you called president twice? So I mean, like,
Yeah.
all college, you're calling college twice, and are you saving the changes and then running it?
Yeah. Maybe a third time's dead chart. Yeah, it still ain't. Oh,
So maybe scroll up.
I found a spot where it like called the whole thing twice, it looks like almost.
Yeah, so what was happening was, for me,
All right, yeah, I
I
see it
could
now.
scroll
I
up.
see it now.
Yeah, for me to see it.
I see it now.
So giving that variation helps people understand, okay, it's coming twice, and that's the reason it's coming twice, because we're talking about different presidents and their timelines. Okay. One more feature I want you to look at here. In the lines of the method, if you look next to the line number, you see a little minus in a circle. Like, for example, next to line 12, I see a circle with a minus. If I click on it, it collapses those methods. So all the methods that I want to not see for now, I can collapse those. And I can uncollapse whichever one I want to uncollapse. So what does it really helps you when you are coding between two pieces of code and there are unnecessary lines which you do not need to see right now. Instead of having to scroll back and forth, you can collapse those blocks. Okay, so now let me introduce another method here. Since you can now easily see that I can see the main and the method I'm coding, public static void divider and then I will call divider between each of my calls. Divider, divider, divider. No. So I'm calling divider 3 times. Every time I call, it will display hyphens. Save the changes and run. And you will now see dividers in between wherever I want to display them. So this is just to show you that how the same method can be called multiple times. And this is the real beauty of using methods, that it allows you to call something multiple times. Okay, is everybody caught up with this? Okay. So let me go back to our ebook. We learn about parentheses and we learn about parameters. We're now adding parameters to methods. We already looked at that. So in object-oriented programs, we use what we call implementation hiding, which describes the encapsulation of method details. It means that a client does not have to know how a method works internally, but only needs to know the name of the called method and what type of information to send. For example, println, you do not need to know the underlying details of println. All you need to know is you can interface with it through system.out. So that's called encapsulation, hiding the underlying details. Okay? The interface to a method is the only part of the method that the method's client sees or with which it interacts. You should know how many parameters it takes, how to call it, and that's about it. You do not need to know how it works. For example, if you're sitting inside a car and you see the speedometer is a visual interface through which you can interact, but you do not need to know how it needs to calculate the speedometer's speed. So that's one thing to keep in mind. Hidden implementation methods are often referred to as existing in a black box. Many everyday devices are black boxes. That is, you can use them without understanding how they work. Okay. Creating a method that receives a single parameter. We already did that, but I'm just going over the details. First of all, every parameter needs to have a data type called the parameter type. And it needs to have a name, a local name. Okay. Why is it called a local name? Because parameter is considered to be a local variable. It only exists within the body of the method in which it is declared. It is not available to anybody outside of that method. Okay. So here is an example that we have a method called calculate gross. It receives a parameter hours of type double, and this parameter is local to the method calculate gross and can be treated like a local variable. We have a constant called standard rate, 22.75. We have a local variable gross, and gross is hours times standard rate, and hours is a parameter, standard rate is a constant, and then we display the output that these many hours at this rate will yield so much as a gross pay. Anytime I need to calculate the gross pay, I call this method, pass the number of hours, and it gives me the gross pay. Okay? Now, let's go back to our example to do something very similar to this one. Okay? Also, one more thing to keep in mind, gross pay can receive an argument of type double. So for example, all of the following method calls would be valid. You can call gross pay with an integer value. It will still work. You can call it with a double value. You can call it with a product of two numbers. So it will first calculate the product and will then pass the final output as the value. You can use a constant and pass a value through a constant. You can use a variable and pass a value through a variable. You can call a method which will return a value, and that value then can be passed as a parameter value. Okay, so something like this we will also use later on in this chapter as we progress through the chapter. Okay, so here the author is showing you different ways of calling the same method. One is through a literal value, 10. Another one is through a value stored inside a variable hours, and another call through another variable called your hours worked. Every time a call takes place, the value gets transferred into hours on this line where the calculate gross is declared, and now hours is representing that value alone that it receives, and that's about it. Okay. Now let's go back to Eclipse. Now let's create another method here. Public static void called program cost. So this method will receive the number of credits, and this method will also receive the cost per credit. Or credits. System.out.println. Total program credits. Cost per credit. And total credit cost for program. I can multiply credits times the cost per credit. And then maintaining the main, the number of credits are 63, and the cost per credit, let's say, is $185.99. So after you are done creating the program cost method, then line number 13 and 14 in the main method to calculate and display the cost credit. Everybody got this?
Almost.
Okay.
And then you said do what after typing all that?
After typing lines 40 through 45,
Oh, right there.
you add lines 13 and 14 in the main, which is the divider and the call to program cost, and we are passing the number of credits, and we are passing the cost per credit.
Where is my error message coming in? Oh, there. Okay. 599, 11, 71, 17, 37. Okay.
Okay, got it? Okay, let's see the chat messages. Are you referring to line number 14, Luke? So doesn't matter what is the data type of the parameter. All parameters must go between the parentheses. If the data type is character or a string, only then you put the values in quotes. If it's a character variable, then it's single quotes, and for string, it's double quotes. But if it's a number, then it's without quotes. One more thing to keep in mind is that the parameters match. So my first parameter is integer, the second one is a double. So that's why when I'm passing the values, my first value is an integer and second one is a double. And single quotes is for the character type. And double quotes is for the string type. So all the parameters, irrespective of their data type, must go within the parentheses. And all the parameters will be separated by commas, but no comma after the last one. So in this one example, we looked at passing one parameter, and we also looked at passing two parameters. There is no limit to the number of parameters you can pass as long as the passing and the receiving side match. Now to the program cost. Let me add one more parameter, and this will be of type string, just so that you can see how string can also be passed in the same method where numbers are getting passed. So string is program name. Okay, that's my parameter, program name. So right here at the beginning of the method, program name, oh, it's prog name, sorry, prog name. And on line number 14, you have to then add one more parameter to the list. So line 14, we added one more parameter, and the parameter list must match. So the first parameter on the receiving end is a string. So on the passing end, the first parameter is a string. String values require double quotes. That's a first parameter. That's why first parameter is in double quotes. Integer must not be in quotes. Second parameter is integer. Third is a double. That must also not be in quotes. And when you run your program now, you will see that the last one displays the program name, followed by the number of credits, followed by the cost per credit, followed by the total credit cost per program. All right. Okay, everybody made that change of passing a string parameter and receiving it and displaying it.
Yep. No. Okay, no, I am. Cool.
By the way, just so that you know, 10.152 is the state code for programming programs, and 1 is for software developer. That's why on your curriculum sheets, you have 10.152-1.
There now must sound actually better. There we go.
Oh, it's okay, Josh. Fine. Okay. Okay, guys. So after this, let's go back to our chapter. Creating a method that requires multiple parameters, and that's exactly what we just looked at right now. So here we see an example where multiple parameters are passed, and multiple parameters are received, and multiple parameters are used. So we have hours and rate in this example, received, multiplied, and then the gross is calculated. A method's signature. Okay, there's a difference between a method signature and the method header itself. The method header is the whole line. Method signature is the combination of the method name and the number, types, and order of the argument or parameter. Like if you're passing 3 parameters or 2 parameters or 1 parameter, that's all. Okay, therefore you can say that a method call must match the called method signature. So when you're calling a method, the call must match the method's signature. So if the method receives a string int double, you must pass a string int double. Now there is one more concept to learn. An argument in a method call is often referred to as actual parameter. A variable in the method declaration is called formal parameter. So wherever you're initiating the call from, that's actual parameter. And wherever you are receiving it, it's called formal parameter. These are just terminologies, okay? Just so that you know. If, that's another concept to learn, okay? Referring to the signature of a method. So if you have the same method name, but different number of parameters. Let's say if the method name is display. You have one version of display with no parameters, another version of display with 2 parameters, another version of display with 3 parameters. What would you call these 3 displays? Overloading. Okay, these are overloaded methods. Same name, same identifier, but different parameter. So that's another concept that we will be learning in this chapter. Okay, let's move on to our next topic, which is about creating methods that can return a value, which are called the value returning methods, or creating methods that return values. All these methods must have a special line towards the end or somewhere, which is called a returned statement. So these methods that have a return statement cannot be void, because void methods are non-value returning methods. So that's why you have to replace the void with some kind of a return type. It could be integer, Boolean, character, string. Doesn't matter what it is, but it must be something other than void. So these are the two pieces of information to remember. One is that you must have a data type other than void. Another is to have a return instruction with a value or a variable matching the data type of the return type that you mentioned in the header. If I have one method called calculate gross with integer return type and another method called calculate gross with a double return type, will this be method overloading? So if I have one method called calculate gross with int return type and another method called calculate gross with the double return type, will this be considered as overloading?
Yes.
Yeah.
Yeah.
No. Remember,
Oh.
Because it's
overloading
one
is
per.
only in the signature and the return
Oh,
type
the
is
sig.
not part of the signature. Signature is only the name and the parameters. Okay. Now, having said that, let's have a look at this code. It is possible for you to call a value returning function, pass it the respective parameters, whatever parameters it need. The value that comes back, you can store it in a variable. The other possibility is that you can use it directly in an output instruction. You can say, instead of storing it in a variable and then displaying the variable, you can directly say, my pay is, and call the calculate gross and pass the parameters. Whatever value comes back will be displayed directly inside the output instruction. Okay? So both of these are possible. The third possibility is that you can call a method which will return a value to you. That value is then used in a calculation, and that calculation is stored inside a variable. So that's a third possibility that you can use it as. Okay. So now let's start working with value returning methods. So let's go back to Eclipse. And let's create a new class. Working with methods. Public static void main. Public static integer square. Integer number. So all this method does, it receives a number and squares it. So integer sq equals to number multiplied by number, and it returns the s squared. Whatever number it receives, it just multiplies the number by itself and returns it back. So in the main method, I can simply declare, I'll use multiple ways of using square. So I declare a variable sq, I call square, and I pass it a number. And then I say, okay, system.out.println, square of 4 is, and whatever is held inside sq. So it tells me the square of 4 is 16. Because I'm passing 4, it is multiplying 4 by itself, and it's returning it back to the main. So basically what you are doing here is that this value of 4 gets passed into num. The num gets multiplied by num, and this value of square is returned on the line where the method call was made, and this SQ will actually hold the value of this SQ, and that's the one we are displaying right here. Okay. There's nothing in the names because both are local names. It's not like since I use the same name, it is making this happen now. Nothing in the name. They're both local to their respective methods. So I'm passing a number. The number is getting squared in a variable, and that variable is then returned back. Everybody got this one?
Yep.
No. System. Oh, there it is. Yeah.
And did everybody understand what we did here?
Yeah. Oh, wait.
Now we will be looking at some variations of this code. So to create another variation of this code, I will click the File menu and click Save As. Click the File menu and hit Save As. And instead of working with methods, I will call it Working with Methods 2. I'm just sticking a number 2 after the name before the .java and hit OK. Who can tell me why line number 2 is red?
Because
we already have a class.
Because the class name and the file names are not matching, okay? Here's the quickest way to fix it. In this case, you can just add a 2, but this, what I'm about to show you is a better approach. Hover over the name and click the link that reads rename. So if the name is way different from the previous name, instead of you sitting there and trying to match and type, you can just hover over the name and click on the rename option, and it will automatically rename it for you. Okay. Now, let's look at the second approach. On line number 10, it is storing the value of the calculations in a variable and then returning the variable. So the whole purpose of the variable is only to store the value temporarily for one instruction. In these kind of situations, programmers often directly calculate and display by eliminating the use of an extra variable. Because all we are doing is we are calculating and displaying and returning. There's no point of holding the value for one extra instruction, because that's exactly what instruction was: store the value of calculation and then return that variable. So instead of doing that, a lot of the developers would just do this. We'll do exactly the same thing. When you run it, it does exactly the same thing. So do not allocate unnecessary memory. That's what it is more memory efficient. Okay. Now, similarly, on line number 5 and 6, what we just did, we could eliminate the use of SQ by simply making the call right here. So you make a call, right there. So instead of first storing the value and then making a call, you can do it like this. Okay, so everybody got this one working too? Did you understand what we did here? Okay, now let's save this example as number 3. And same deal. We hover over and save it as. Now let's look at another variation of the code where we will create a special method to first accept a number from the user, and it will be that number that we will then pass to the method. So let's create a method here. Public static int number, or so let me call it input. Okay, let me see how many of you remember this from first week. Which class object do we have to declare to accept an input from user?
Scanner.
Scanner. Okay, scanner equals to new scanner system.in. Okay. Why is that line giving me an error?
Because you need to import the scanner utility.
Okay, so hover over scanner and click on import. It will automatically add the import line for you. Okay, now system.out.print, enter a number, integer number equals to scan dot next int, return number. So that basically allows me to create a scanner object. Using the scanner object, I am accepting an input from user, storing that in a number variable, and then returning the number variable. So now in my main method, I will declare a number variable which will call the input method. And whatever number comes in, it'll say square of that number is, and then I'll pass that number to the method square.
Okay. Scan system and system out print. I'm getting an error line. Let's see what you say. Can't be resolved to a variable. Static. Mine is for when I put the variable num under the
Oh.
void main.
So you're basically referring to line 6, my line 6,
7.
my line 7. Okay, so where are you getting that error on line 7? Here or here?
Oh, hold on 1 second. I just realized something. All right, that was my mistake. I figured it out. I forgot the line right above it.
Oh, okay.
Or I should say, I didn't replace the old line 6 with the new line 6.
Okay, Luke, did you got it? Did you get it too? Got it fixed?
Okay.
Line number 6. Okay. Your line number 12, you have this method is without any problems, right? Has no errors in them, lines 12 through 17. Yes, okay. And then, but your line number 6 is giving you a problem. Okay. Is it possible that you can share your screen? So I'll stop sharing and I'll let you share your screen. Let's have a look at it. Oh, okay. Okay, that's fine. You can switch yours and then you can share it. We can have a look at it. So how about the rest of you? Everybody got it? How did you understand the flow of the code? That how we are making a call? Okay. Okay. In the meanwhile, Luke is connecting. Jocelyn, can you share your screen? Let's have a look at it. Okay, okay, so probably Luke can share his first, or whoever gets connected first can share theirs. Okay, so Luke is coming up. Luke is coming up here. Okay. Okay. Okay, the spelling mistake. On line 13, you wrote input. You need to get rid of that extra T there. That's it. So save changes, and that should do it. That's another thing to keep in mind. Anytime you make a call to a method and the method name errors out, then check the spelling. These are all different, learning things. Sometimes little mistakes, and we're like, why is it not working? Because it's easy to overlook some of the stuff. Even, I mean, like, and one of the reasons that we do that, because in English language, when you read a word, you not necessarily make sound of every letter in that word. There are certain words that you can have said without using some letters in there, because those letters don't even produce any sound in that word. So that's why when we are used to a reading like that, it's easy to overlook some of the letters in the variable names. Jocelyn has connected her second Zoom session, so Jocelyn will be sharing it pretty soon. And here is, okay, here is the code. Okay. First of all, save changes. Second of all, on line number 20,
5.
flip over scanner. And oh, hold on a second. Where?
Public class, working with methods 2 should be 3.
No, but she is actually in working with methods too.
That's what I'm saying. It should be 3
Right.
instead of 2.
But that should not error out because her file name and class name match. Can you? Oh, because okay. You have classes string and system. Did you created those classes under week2.java on the left-hand side? On the left-hand side? Well, I don't understand why you have string.java and system.java created as classes there. Can you right-click on week2Java on the left-hand side, that package, and delete that package? Delete it. Yeah, okay. Because what's happening is, in your case, it is constantly referring to local classes, okay? Similarly, if you scroll back up to the top, line number 1, you see a little plus next to it. Click on a plus. Okay. Okay. Get rid of all 3 of these lines. Delete all 3 of these lines. Okay. Okay. Now save changes. Okay. Now, can you close this tab altogether? This working with methods to close the tab. Double, oh, all of your classes had problems from the beginning. Oh, this one is not complete. Close that. Okay. Okay, let's double click on working with methods too. Oh, I see the problem. Okay. Can you create a new project? Can you please click File menu at the top and call it New Java Project? Okay. And call it week 2. Okay, and then hit next, and then hit finish. Okay. Now, open that week 2 that you have up there, expand it, click the arrow next to it. Okay, there's a strange error there. Okay, I wonder what's the reason. Leave that there. Open your working with methods.java. Okay, even that has an error. And when you hover over working with methods, what do you see? Strange. And if you right click on week 2 week 2, no, not this one, the one we just created, right? Go to new and create a class. And let's call it test, and check public static void main checkbox and click finish. Strange. It is not recognizing any of your classes. And when you open your week 1, did everything work in week 1? Open week 1. Yes, okay. And you did not have this problem in week 1. When you open SRC folder, oh, it's probably the system library problem, maybe. Okay, that's what it is. Okay, close that. Close that. Okay, and then right click on week 2 and delete week 2. Okay. And don't forget to check the checkbox up there. Oops, anyway. Click File, New Java Project. Okay. Go ahead, click on it. And call it week 2. Okay, let's put a B there after 2. The letter B, week 2B. Okay, now where you see use an extension environment, execution environment, SE19, click the drop-down box. And from that list, choose 17. Okay, now hit next and finish. Okay, that's what you have to do, I think. Close that window that you have open here. Yes, that one. Okay, now right click on week 2B and new class. Okay, let's call it, test, and check public static void main, check that. And
What about the inherent abstract methods?
so that's fine. So now what you will do is copy all the 4 files that you have, college info through working with methods 3, copy all 4 of them. So click on the first one and shift and click on the last one. No, you don't have to double click. Okay, just click on the first one and hold the shift and click on the last one. Okay, then right click anywhere in the selection and copy. And then right click on week 2B and paste. Okay, now go to college info 2. Okay, there are different errors that you have to fix because you're missing a lot. Why were you not coding? Any reason? You did not coded anything here except for that one method. Was I going too fast? Or, oh, okay. Okay, at least you should have coded, despite the fact you had errors. Um, and now what I will do to speed you up, I will share with you the source codes that we have written because they're going to take you forever to catch up to what we have done so far. So you can stop sharing. And I will give you files in the chat. You will download those files, and then you will drop it. You can drag it and drop those files from the downloads to your okay. So let me go to the location where my files are. Okay, so all 4 of these files should now be available in the chat. You will download them on the computer that you are. And then once you're done downloading them, you can drag those files and drop it on your package. And if it asks you, do you want to override or replace the existing files, then you can choose yes. And let me know when you have done that and the errors are gone and you're able to run it without a problem. So this was the last example that we did. Just as a refresher, that we took an input from the user by calling the input method. So let me run this one. So enter a number. So what's going on is line number 6 is making a call to input. Input is running the line 14. I enter a value. As soon as I hit enter, that value goes to the variable on line 15, which is num. And that value on line 16 is returned to line number 6. So from 16, as soon as I hit enter, the value is returned. From 16 to 6. And is held inside num, whatever value I enter. And that num is being displayed over here. And then when I say, give me the square of that num gets passed to square. The square of the number gets calculated, which is number times number. And then that output is placed in place of this instruction. So if I enter 5, I get 25. Okay, so that's how I get my 25. Okay, Jocelyn, are you up to speed now? Okay, so were you able to drag them and drop them in your project? And did you run it within your project? Or do you have any errors when you drag them and drop them in? Okay, awesome. Okay, guys, now let's save this example as working with methods 4. And we will hover over the 3 and replace it with 4. Now, what changes I want to make is this, that instead of accepting an input from user, storing in a variable, and then displaying that is a requirement over here. Why is that a requirement over here? Because I'm using it twice. So when you're using it more than once, you need to store the value in a variable so that you can use it multiple times. However, on line number 13 through 16, num is only being used once, and that's it. So what I can do is I can directly move the scanner instruction in the return. So what this will do is enter a number. It will ask for a number in the return instruction, take the input, and send it to the calling instruction line 6. So I do not need that extra instruction to hold the value in a variable only for one line to send it. So now when you run this and you enter a value, works perfectly fine. It's just like it's more memory efficient. Okay, everybody got this one working?
Yep.
So we will save this one as number 5. The reason I'm doing it in steps and preserving all the steps so that you guys can see the progression. What we will do next is we will introduce, okay. We'll give one more. Like, give us okay when you're done, Luke. Okay, good. So we saved it in our fifth variation. So let me give you another concept here. In object-oriented programming, there is a concept of a variable and there's a concept of an instance or an object. How do you differentiate between these two, variable versus an instance or an object? Variable versus an object. How do you distinguish or differentiate between the two? We learned about it in chapter 1 last week. It is by their data type, or probably maybe chapter 2. If the data type is a primitive type, it is variable. If the data type is a reference type or a class type, it's an object. Okay? If the data type is a reference type, it is an object. If the data type is a primitive type, it's a variable. Everybody clear on that? Okay. How many objects can you find in this program? Give me a count. Don't give me what they are. How many objects can you identify or find in this program? Okay. So answers are coming in chat. Okay. Let it roll. Okay. So we got threes and twos and threes and twos and threes and twos. Okay, cool. So let's ask those who said 3. What are those 3 that you identified? You can write in the chat which 3 you identified. Let's see if everybody who said 3 is on the same page.
I thought when it said 3 that it was
Sorry to cut you. Write it in the chat, please.
okay, my fault.
Dylan, square is the name of the method on line number 9. It's not an object. See, objects are not methods. And num is a variable. Remember, its data type is primitive. So for anybody who chose num and said it's an object, it's not an object because its data type is primitive type. So these two items go out the window. Coming down to args, yes. Args is of type string. A string is a class, so args is an object. Okay. So Dylan, did that make sense to you why square is not an object? Okay. Now, scan is an object, but not scanner. Scanner is a class. Okay. So scan is the object. So scan, args, and Jack got it. Out. Out is also an object of print stream type. You can hover over and you can see its class, print stream. Got it, everybody? 3 objects. Out, scan, and args, because their data type is class. Okay, now let's come to the second concept I wanted to introduce to you. Objects don't always have to be named objects. So there's a concept in Java programming that objects can be named and objects can be unnamed. Now comes the question, why in the world would you want to have an unnamed object? For the same reason I told you that in order for you to save memory, you do not have to declare a variable if it is only used once. For the same reason, an object does not have to be instantiated if it is only to be used once. Which object did we declare that is only getting used on one line? Which object did we instantiate it that is only used on one line? Now comes the question, how many objects am I instantiating? I never instantiated args. That's part of the syntax, right? I never instantiated out because it's part of the syntax of system. The only object I instantiated was scan. Okay? Again, Luke, square is a method. It's not an object. Chloe, square is a method. It's not an object. Objects never have parentheses next to them. Okay? So scan, so first we identified that there are 3 objects, which are args, out, and scan. Args, we never instantiated. It's part of the parameter call to main. Out, we never instantiated. It's instantiated inside system class. We just simply called it. So now comes the question, what is instantiation? Instantiation is declaring an object by name and allocating memory for that object. Okay. So this is the syntax of instantiation. You need to provide the class, you need to provide the object equals to whatever you see on the right-hand side is part of memory allocation. We will look at the detail when it's right time to look at the details of the right-hand side, but the word new is used by Java to allocate memory. Okay? So is everybody clear on which object we instantiated?
Yes.
Now, let's go to that object is only used on one line, which is line 18. Otherwise, there is no use of that object. In this situation, we can simply, I will comment out this line so that you have it as a reference. And where I use scan instance, instead, I will create an instance on the fly. How do you create an instance on the fly? New scanner. System.in. That's it. That's called unnamed instance or unnamed object. I created an object on the fly, did not give it any name. It will be used and it will be thrown away by the system at the end of the execution cycle or at the end of that instruction. I know they're little small concepts, but I want you to understand them. That's why I'm using smaller examples. And they could be a bit confusing in the beginning, but when we use them over and over again, they may sink in. So all of these measures are done by developers to not only decrease the code lines, but also to write more memory efficient code. But eventually they end up writing code that is not very easy to read. That's why they have to write documentation for that. So think about it. Basically, if I remove the commentary, this whole code is only 2 lines. Okay, so now when you run this example and you enter a number, the output is exactly the same, right? So how many code instructions did we write in this example? 6, 7, right? 2, line 10, 3, line 17, 4, line 19, 5. We wrote 5 instructions. Now, if I were to go back to our third variation, how many instructions did we had here? 7. Okay. And from 2, it was not customizable. So that's why 2 doesn't count. So it's basically 3 versus 5. Okay, so I think we covered this topic here. And we already talked about the local, that all the parameters are local. So look at this code here. We use extra curly braces here. Not that developers would ever do that, but just so that you understand. So any variable declared in the outer curly braces is available all the way through. Any variable that is declared within the inner curly braces is only available within the block. So scope is pretty much how far a variable can be used. That's the scope of the variable. If the variable is declared outside of all the methods, it is called a global variable. If the variable is declared inside a method, it is called a local variable. So that's basically the concept over here. Let's take a break here. When we come back from the break is when we will start to look at overloading methods. So let's take a break till 2:20. So I'll see you guys at 2:20. So before we went on break, we were talking about that now we will be looking at overloaded methods. And I briefly told you about what is an overloaded method. And overloaded methods are those methods where signature has only one variation, and that is in the parameters. The names of the methods or the identifiers for the methods are exactly the same. So multiple methods with the same name and their parameters are different. For example, if I have a method called display with one parameter of type integer, and I have another method called display with one parameter of type string, will this be overloaded? They both have one parameter, each one of them. Their names are same. One is of type integer, another one is of type string. Are they overloaded?
Yes.
Yes, they are. Yes, they are. Okay. So overloaded doesn't mean that you need to have different count of parameters. So one variation of overloaded is that one parameter has one version has one parameter, another version has two parameters. That's one variation of overloaded. Another variation of overloaded is that they have the same number of parameters, but their parameter types are different. So the 2 points to look over here are the list must have different number of parameters. That's one way. The list must have parameter data types in different order. That's also another variation. So for example, there are overloaded methods of display with 2 parameters each, but one has a variation of integer string, another one has a variation of double character or double string or string double. You know, there is a variation in the order. So here we have a method called calculate interest with 2 double variables. So that's basically considered to be overloaded. Okay. Now look at this example here in the you do it section. Okay. We have a method, we have a class called demo overload. In this, we have 3 methods: display date, display date, display date. One takes 1 parameter, one takes 2 parameters, and one takes 3 parameters. So the display date method that takes 1 parameter is the month. The display date that takes 2 parameters is month and date. And the display method that takes 3 parameters is month, date, and year. And this is considered to be overloaded. And in the main method, we are calling each one of them. And each display, whenever display date with 1 parameter is called, only that one is invoked. The one with 2 parameter is invoked when you call with 2 parameters, and one with 3 parameters is invoked when that one gets called. Okay. So how about you guys do this example from the book directly? Create a class called demo overload with a main method. And let me tell you, in your books, that is page 104. So I will stop sharing so that you guys can directly look into your books. So that's page 104. The main method, and it has 3 additional methods that go in the same class. And when you run it, this is the output that you will get. And give me a green check when you guys are done with this one. So that's page 104. You do it overloading methods.
Oh, that's what I forgot.
So, Luke, I just shared the screenshots from the book for the 6 steps. So since you can't open your book for whatever reason, you can then follow by downloading these images. So don't forget to click green check reaction when done. Okay, so Jacob, Alex, Chloe, and Dylan. Any questions, or you guys are just still coding? Almost done, okay. Just wanted to make sure that you guys don't have any questions or have any errors. Okay, Alex, is that an error? Or is it like something else? Oh, okay. Okay, but you have those screenshots, right? So, okay, cool. So for the there's one more topic to cover, and then after that, I will be putting you guys in a breakout room where you would have to use your books. But maybe, when you are in the breakout room, one of you could share your book on the screen so that those who don't have it in your group can actually see um, the activity as well. So I know Alex is wrapping up, Dylan is wrapping up. Chloe, are you also wrapping up? Or are you done? Or need help? I don't know, whatever is the case. Okay, okay. So there's one other topic related to ambiguity with the overloading. So for example, if you look at public static void compute, rather let's have a look at this example, calculate interest. Calculate interest has two variations and it is overloaded. First variation is integer double, second variation is double integer. Apparently, everything will work fine if you make a call to calculate interest and pass an integer and a double, then the first variation will be called. If you pass a double and an integer, second variation will be called. The problem will come in if you call and pass two integers. Why that will be a problem? Because for that, there is no exact match, and both calls will qualify for that, because double can actually take integer values. And that's where the ambiguity will come, and the compiler won't be able to figure out which version of the two to use, and the program will not compile. So that's one thing to be careful about, that your code doesn't have any ambiguity in it. Okay. A few don'ts to consider: never place a semicolon in the line of the header. So where you are starting your opening curly braces, never put a semicolon in the line of the header. Don't try to use a variable that is out of scope. So if you have to use a variable, make sure that it is in the scope. If the variable is being used and it gives you a red underline, that clearly is an indicator that variable is not in scope. Don't assume that a constant is still a constant when passed to a method's parameter. It was constant only in the called method, but not in the caller. Or so whatever is the case, you got to make sure. Don't try to overload methods by giving them different return types. So return types don't create overloaded methods. Now, the group activity that I will be putting you guys to work together is at the end of the chapter review questions. There are 20 review questions. So what I'll do is I'll put you guys in breakout rooms, and we're going to time this activity. So let's say we'll create breakout rooms with 2 to 3 people in it, okay? And we will time it for, let's say, 20 minutes. Yeah, let's see, 20 minutes. If you get done with all the questions in 20 minutes, well and good. If you don't, then anyway, we'll be discussing it together. So your time starts now. You can join your rooms. And then you have display number squared. So these are the 3 additional methods that we have created because of the specifications. So we have declared 2 variables, accepted their values, and now we are passing the values into these methods. So we are calling display twice the number, we are passing the first number. Display number plus 5, we are passing the first number. Display number squared, we are passing the first number. And then we are repeating the same for the second number. So because it says pass each value to the methods. So that's why, and what we are doing inside is display twice the number. So that's why we are just multiplying it by 2. Now I took a liberty to also declare a constant because we covered that in chapter number 2. So why not declare a constant and work with the constant as a refresher? You don't have to do that. You could have taken a slightly different approach as far as the body of the methods is concerned, because there were no specifications given. Then I used the same approach for the second method. The only difference was I changed the factor to 5, and I changed the operation from multiplication to plus. And in the third one where it said square the number, this is very similar to the method that we already coded in our examples, where I was simply squaring the number. So that's the approach I took here. Your approach could be different. Probably you guys had a different approach. Some of you, right?
Yeah, very slightly, but yeah.
For the most part, it was similar. Okay.
Mine,
Yep.
what I did was I made the methods take both A and B at the same time.
Oh, okay. And then you were working your way like that. Okay.
Yeah.
So what I'll do is I will drop the solution in the chat, so everybody will have this one as well. So you don't have to sit there and quickly try to copy, you know. So you have, everybody should be able to find that file in the chat.
Thank you.
No problem, no problem. So again, the whole idea was, the only reason I made you guys do this for two things. Number one, working together in a team of two. And number two, trying to solve something in in a limited time. That's it. And I was not expecting, you know, everybody will be done, but it's just like, you know, when you are used to of these kind of things. I remember many years ago when I was in my undergrad program in Chicago and I applied for a position at one of the, it was kind of a company that would deal with credit card companies. It wasn't like a collection company, but I don't remember. It's like such a long time ago. And one of the first questions they asked in an interview was, can you work under stress? That was like one of the first, I think it was, if not first, maybe in the top 3 questions. They said, because we have a very stressful environment. We work with banks. Sometimes they give us very small window to deliver. So sometimes we have to come on weekends and code. And these are the times when coding from home was not even an option, right? So I'm talking about, that must be 23 years ago, at least 23, 24 years ago or something like that. Anyway, so things were different back then, but I'm just saying, you know, some workplaces, they know that their culture is such that, so if a person is used to of a little bit coding under stress or coding under a limited timeline, then at least you're used to of seeing that kind of stuff going. But anyway, that brings us to the end of our today's class. And I hope you learn and be able to retain what you learn and be able to apply during the week what you learn. And don't procrastinate with your homework assignments and your quizzes. Each and everything counts. I've seen kids, they were shy of A because they missed 2 quizzes or 1 quiz. Or they got a C because they missed most of their quizzes. I mean, little things. And then think about it, you going for an employment and you're showing your transcript, and how does a C looks in your major? It doesn't looks good. When you're applying for a programming position and your programming courses don't have good grades.
Well, especially if anybody wants to get an internship during, especially like during school here, you know. Like,
Yep.
I don't know. Your GPA can totally help you out with that.
Absolutely, absolutely.
And
thanks for
scholarships and stuff.
say it again.
I was just saying, like, and also sometimes scholarships, grants, or even if you're looking at getting into another college to finish with a bachelor's or something.
Yep, all of these things, because there are scholarship programs through foundation, and that's one of the things that they look at is your GPA and how you are performing in classroom. So when they send us recommendations, you know, we can only fill out the recommendations based on what we see in the grade books. So that's very, very important for you to take it seriously and get going now, as we are still towards the end of week 1. Whatever I assigned you last week is due by the end of the day today. and whatever I'm assigning you today will be due by next week, Thursday, midnight. Okay?
Sounds good.
Any questions? Okay, how was the learning?
Pretty good.
Cool. Had fun? Learned something new?
Yep.
Or help you clear some of your concepts? Because we spend a lot of time earlier learning about little concepts like static, non-static, for example. So those concepts will be very handy for chapter 4. I knew that we will not be getting into it today, but giving you information ahead of time and then reinforcing it may probably help you more than having to just get it once and then forget about it, kind of a deal. Okay, guys. Take care. Have a good one. Bye.
Yeah, you
Saad,
too. See you next week.
Yep.
got a question for you if you don't mind.
Yep. Go ahead, Alex.
So I'm working with a outside resource center, and they're gonna help, and the social worker is gonna help me set up a resume.
Uh-huh.
My question is, should I include like what we learned in classes from last semester?
Include in what sense? Like, what sense?
Should I put like, I believe she said there's a section on the resume called skills, base understanding of C#, base understanding of SQL,
You
stuff
can,
like that.
instead of saying base understanding, when you're listing your skills, you can just list under programming languages, C#. You can list Java, you can list CL, you can list under operating systems, IBM iOS and Windows. You can
I'm sorry. Can you say that? You said C#, SQL,
well,
CL.
yeah. So your program, your languages are C#, Java, CL, SQL,
CPL.
CL, control
Oh,
language.
CL. Yeah.
Yeah, control language.
I think that's Java.
You're learning it now.
So don't put. You wouldn't say put Java.
No, you can. You can. You're learning it now. I mean, like, you're not going tomorrow for a job interview, right? You're building a resume.
No.
So when you're building a
Yeah.
resume, so I put in the chat for the languages. And are you learning internet programming this semester?
Yeah. HTML5.
Yes, yes. So HTML, CSS, JavaScript can go in web technologies, okay? And for databases, DB2 UDB and SQL Server and MS Access, all of them can go because I remember I taught you guys both of them, MS Access and SQL Server. And in the IBM class, we learned DB2 UDB, so they can go in the databases.
So the top
Then
two
you
would
are
be
familiar
language.
with RDI, Rational Developer, Rational Developer for I. You know how to code in Visual Studio, right?
Yeah.
And you are using Eclipse this semester. Okay, do you know any Microsoft Office technologies?
Not enough where I'd want to put it down.
Like Word, for example, you know Word?
Barely.
Okay, so what do you use for your documentation? Do you use Google Docs?
I mean, I do use Word, but it's
They're not
it's
hiring you for an office worker's position. So you don't have to be master in Word. But they should know
okay.
that you know how to work with documentations. They need to know that you can, do you know some kind of a presentation software? I mean, you're not just going out there with no information outside of the little box. So anything that you work, see, they are not looking for mastery, you know? There were times when we
Yeah.
used to put the levels. You're familiar with it. You can use it. You have used it. You have worked with it. You can put it.
Okay, thank you for the advice and whatnot.
Yeah, I listed all of them in the chat so that you won't have
Yeah.
to about having to type those. And anything else that you can think of that you probably have used, you can list it. It has to be relatable, you know. That's
Now, should I do HTML or HTML5?
HTML is understood. It's just like, you know, you don't put Visual
Okay.
Studio 2023, right?
Okay.
Yeah, you don't say .NET Framework 6. You just, you know, so it's
All
understood.
right.
Yeah.
Thank you.
Mm-hmm.
Try and rest up and heal up.
Oh, thank you.
You got another appointment, what, next week you said?
Yeah, Monday. They want to see if it is even healing or not. So that will help them and make the next set of decision.
All right. Well, hopefully it goes well.
Yeah, thank you. Thank you.
All right. Have a good weekend.
You too. Thanks. Oliver,
Thank
do you
you.
have a question for me?
Yeah,
Okay.
so how would this class compare to AP Science A?
Okay, AP Computer Science. Did you take AP Computer Science?
Yes.
Okay. AP Computer Science only works with concepts and then transitions into some data structures. And AP Computer Science, I don't remember if it goes into graphical user interface, does it?
It does, yes.
It does. Okay. Okay. So it does some it does swing or does it do Java effects?
We use AW, swing and FX, so
Okay, you do both.
not
So
much,
probably
but
the curriculum has changed because I taught that course back in 2000 when it was first launched at Lakeview. I was the one who taught that course. So and then after that, Mr. Overrocker has been teaching that course since then. So all the changes that have taken place, I'm not aware of those changes. Uh, it's very similar, but at the same time, it's different. I don't know how he teaches that class. Does he teaches it more towards the exam, or does he teaches it as a language?
has a language, so it was really like standing, so like he taught some, but then had us do like, try to make us do it so that we learned.
Okay, okay. I don't know exactly up to date what AP Computer Science is now, so I can't really answer that question in particular. But you probably going over the chapters in the book can answer that question better as to, you know, how well it relates to that. I don't know, whatever we have done so far, you might already know a lot of this stuff if you've done AP Computer Science.
All right, yeah, thank you.
Yeah, so, and we do not have any equivalency for AP Computer Science. When we tried to do it a long time ago, and that was on the old curriculum set, the old curriculum did not align properly with our competencies. So we didn't do any kind of competency alignment with AP Computer Science.
All right. Is there like a web page that I can look at just to show like the competencies that we're supposed to like know at the end of the course? Is it in your syllabus?
Yes, you probably, hold on a second. So it's mainly revolved around the Java constructs. So if you are looking at the chapters in the book, that is pretty much 80% of the competencies are right there. Towards the end of the class, if we have some time, and sometimes we finish our book before we reach the end of the last week, so we go in some special topics outside of the book. But other than that, the chapters in the book is basically are a good measure for you to see, you know.
All right. Thank you so
No
much.
problem. Take care,
Bye.
man.